what we're doing or starting this off with is factoring. Now, I hope y'all enjoyed the nice long break. It was nice. The extra days that we had over last year was nice to have. But factoring, we've done factoring. We're going back over it. And part of the reason we're going back over it is the next chapter are rational equations. Factoring is going to be very helpful in being able to solve these rational equations, dealing with rational expressions. Factoring is very helpful and essential for that there. So instead of jumping straight in to the next chapter, we're going to go over factoring, which hopefully by this point, so we've seen it a few times now. Be nice way to just kind of ease back into the semester. Now, factoring, especially quadratics, we had 5 main steps. And the first step, and this is beyond just factoring, it's a good step in general when trying to solve or simplify, is to see if the expression has a greatest common factor. If there's something that would go, in this case here, all 3 terms. So we're looking for a number or expression or term that will go into both. Just don't leave it blank.
Let me look in my bag. I'll see.
I don't know. It's okay.
Actually, no, I did.
If I don't have one.
Hey,
sorry.
Mr. McClendon.
Rick already booked my heart once today, so
I'm gonna look for you.
I don't know. I can't remember.
oh, hey, Rick, I got mine. Great.
Fail.
I don't care. I know you think what? Wait, bro, what? First time you filled out again. No, I did the front page, bro. No, you didn't.
I have no.
Yes, I did. Look, my boy.
Brag,
Oh, it's
brag, brag.
I'm just freaked out.
I'm waiting to break. I know he has it.
Here. It's not all the way filled out, but there's some stuff.
Yes. Thanks, bro. I'm out, gang.
All right. I'll definitely hang on to that for tomorrow, because there's the second part of that test. So when we look at these 3 terms here, b squared, 12b, and 20, we're first looking for a greatest common factor, a term or expression or number that will go into all 3. In this one here, there is no greatest common factor between all 3 terms. One of the ways that ways that we know for sure is, especially looking at the first term, b squared, there's no number with it. So most likely there's not going to be a greatest common factor with numbers across all 3 besides 1. And if we look at the third term, 20 doesn't have a variable. Okay, so there is no greatest common factor across all 3. So we can move into step 2. Our 2 sets of parentheses with 3 spaces. Our third step is to find the sign. If the third term is positive, then the signs are the same. And match the sign of the middle term. If the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. So if we look at this here, the third term in our case is positive. So the signs are the same and match the sign of the middle term, which is also positive. So the signs for our factors are both positive. Now that brings us to step number 4. Find the factors of the first and third term. I might as well go on and put the last step. Step number 5 is to plug in and check to make sure we got it factored right. Fourth step is to find the factors of the first and third term. And our last step is to plug it in and check and make sure we got it right. Now, as we're looking for the factors of the first and third term, first term is b squared. We're looking for what multiplies together to give us b squared. Well, there's only one thing, and that is b and b. Because whenever we have that b squared term, b times b, b squared. Now, the third term, factors of 20, there's more than one. There's 1 and 20. 2 and 10, 4 and 5. Which one do we want to try first? 2 and 10. So we plugged our factors in, and the last thing we need to do is check. Now when we check, there's a few that, especially some books say that we need to multiply the whole thing through and make sure that we get back what we start. Now there's 2 multiplication steps that I don't feel completely necessary. It's not necessary. I just feel it's a little redundant. And one of those is b times b. Because b times b is b squared. Well, where did we get b and b from? The factors of b squared. So it's going to get us back to b squared. The only way it won't is if we got the wrong factors of the first term. And the other one is, well, our 2 and 10. Because 2 times 10 is still 20, but we got 2 and 10 from the factors of 20. So as long as we're getting that first and third terms factors right, there's no real reason to check those 2. Now the main one we do need to check for is the 12b, the middle term. And we get the middle term from what is, you use FOIL, the first and last, in our inner 2. And we need to check this here to make sure we do get the correct middle term. b times 10 is 10b. 2 times b is 2b. So we have positive 10b plus 2b is positive 12b. Is that our middle term? So these here are our correct factors. b plus 2 times b plus 10. That's it. Questions on this here? Hopefully this is a little familiar from doing this a few times last semester. All right. Luckily, as y'all know, it doesn't take that long normally to factor. It just takes a while to write the steps. Let's look at this one here. A squared plus 4a minus 32. Is there a greatest common factor between these 3 terms? No. So we'll move on to step 2, our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Here, the third term is negative. So the signs are opposite. One's going to be positive, one's going to be negative. And really at this point, it doesn't matter which one we set as the positive sign, which one we set as negative. We just need one to be positive, one to be negative. Factors of the first and third term. What are the factors of a squared? A and A. Are there any others? Nope. And whenever we just have that one set of factors, might as well go on and plug them in. Now, factors of 32, unfortunately, there's not just one. I always start with 1 and 32, 1 in the number itself. And then I just start increasing from 1 and checking factors. 2 is indeed a factor. 2 and 16. 3 is not a factor, but 4 is. 4 and 8. 5 is not a factor. 6 is not a factor. And that's it, because 5 doesn't work because the number does not end in 5 or 0. 6 is not a factor because both 2 and 3 have to be factors for 6 to be a factor. 7's not a factor, and we've got them all. Now, looking at these three here, which one do we want to try first? 4 and 8. And now we check. A times negative 8 is negative 8a. 4 times a is positive 4a. And negative 8a plus 4a is minus 4a. Is that the middle term we wanted? No, but yes, because we wanted 4, yes? Did we get 4? We wanted it to be what? Positive instead of negative, yes. If we get the correct number but wrong sign, flip the signs. Now for this here, switching the 4 and 8 or switching the signs works just fine. But especially when it's not just A and A, it's easier to switch the signs. Because if we were going to switch the terms, we'd really have to switch the A and A terms and the 4 and 8. But switching A and A really doesn't change anything. So really the only thing we actually do switch is the 4 and 8. But that's it there. Questions on this here? We remembering some of this coming back to us a little bit? Yes. X squared minus 17x plus 72. Greatest common factor. Is there one? No. So we have what? 2 sets of parentheses with 3 spaces. Signs. Negative and negative. Since the third term is positive, the signs are the same and match the sign of the middle term. What do we look for next? Of the almost, not second, first and third term. Factors of the first term. Factors of x squared would be x and x. Now we need to find the factors of 72. And again, I always start with 1 and 72 and just start going up from there just to make sure we don't miss any, because it's easy to miss some if we're not paying attention or just not looking for them. Because 1 and 72 work, 2 and 36, because 2 is going to be a factor since it is an even number. Is 3 a factor? Well, one way we can check and make sure is if you add the digits together. So 7 plus 2 is, if the sum of the digits is divisible by 3, then the number is also. So 7 plus 2 is 9. 9 is divisible by 3. So 3 will go into 72. Or we can just say 72 divided by 3 is 24. 4 is also a factor. It wouldn't be 16. Because it would be, I think it's 18. 72 divided by 4 is indeed 18. Is 5 a factor? No, because it has to end in what, 0 or? It doesn't. Is 6 a factor? Yeah, 6 is a factor if both 2 and 3. Since both 2 and 3 are factors, 6 has to be a factor. And it is 12. 7, is it a factor? No, because 7 times 10 is what? 72 is way too close to 70. Because 70 and then 77. So 7 is not a factor. 8. Is a factor. 8 times 9. Now there's a way to know that we're done. Because if we look at the left and right sides of this here, what's the next number after 8? 9, it's already listed. Because when the left and right sides meet, we have all the factors. Now looking at all those there, which one do we want to try first? 8 and 9. Let's check this here. X times negative 9 is negative 9x. Negative 8 times x is negative 8x. Negative 9x minus 8x is negative 17x. Luckily, unfortunately, we can't type negative 9x minus 8x in the calculator, but the calculator will do negative 9 minus 8, because since they are like terms, they will combine. We combine the coefficients. That is the correct middle term. And we get this here. Questions on this so far? All right, guys. Questions on any of these so far? Do we feel comfortable with these factors? Do we need to see another one of these here? All right. So I'm going to skip that. Well, if you want, minus 10. Because if you want the factors for this one here, it'd be x minus 10 times x plus 3 would be the correct factors. And this next one would be p plus 5 times p plus 10. Okay. Because there are a few more that I want to look at. This here is one of them. This one here is a little bit different than the other ones, but not by a lot. Because if we look at this one here, 2r squared plus 6r minus 8. This one here is the first one that does have a greatest common factor, and that greatest common factor is 2. Now, anytime we do have a greatest common factor, factoring that out does make these a little bit nicer to factor. It doesn't mean that they're impossible to factor without factoring that out. If we left it in, we could still factor it. But in a lot of cases, it makes it a lot nicer to work. Because when we factor this 2 out, really what we're doing is we're dividing each of these terms by 2 and moving that 2 out front. So our 2r squared divided by 2 leaves us with r squared. Plus our 6r divided by 2 gives us 3r. Minus 8 divided by 2 is 4. Now the sign doesn't change unless we divide out by, say, negative 2. Then we would switch the signs. But the only reason we would divide a negative out is if our r squared, that biggest term, was negative. That way we can keep that first term positive. Questions on this so far? But now the rest of the steps are the exact same as we had before. We'll have our 2 sets of parentheses with 3 spaces. We still need that 2 in front because, again, it's still part of the problem. Now we find the sign. And here the third term is what? Negative. So the signs are almost opposite. Because if the third term is positive, then the signs are the same and match the sign of the middle term. If the third term is negative, then the signs are opposite. Factors of the first term, factors of r squared are r and r. Hopefully we got enough of that over the past few weeks. Yes, hopefully you did. No? R and R.
Isn't that insurance?
R and R is rest and relaxation. R and R. All right, guys. Factors of the third term. Factors of. All right, guys. Focus in. Factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 1 and 4. Which one? 4 goes first. 1 goes second. All right, guys. Now we check it. Now this time we're checking to see if we get 3r and not 6r, because again we're looking for our middle term after we factored that out. R times negative 1 is negative r. 4 times r is plus 4r, giving us a middle term of positive 3r, which is what we wanted. So really having that greatest common factor doesn't change a whole lot. We just factor it out and then go from there. Questions on this so far? Are you starting to feel a little comfortable with this here, remembering how to do these? All right. 9 or 12, which one do y'all want to do?
12.
9 or 12? 12? 5r squared minus 30r minus 135. Is there a greatest common factor between these three?
Yeah.
5. So the first thing we're going to want to do is factor that 5 out. And again, what we're doing is just dividing each of these terms by 5. So our 5r squared, when we factor the 5 out, we're left with r squared. Minus our 30r, after we factor the 5 out, 30 divided by 5 is 6r. Minus 135 divided by 5 is 27. Yeah. I mean, yes, rubber does come from trees.
Actually,
Yeah.
Ricky,
Most rubber in tires that we use is a synthetic version of it because it's a very arduous and long process to get rubber out of trees and get the material out of it. Yeah. But it's not been since World War II that it's been 100% natural rubber. We've found a way to make a synthetic version of it, which is cheaper and more efficient.
and we're ruining the world.
All right, guys. Let's find the sign. The sign for this here. Third term is what? Negative. Since the third term is negative, the signs are opposite. Factors of the first and third term. Factors of r squared are r and r. Factors of 27. 1 and 27. Is 2 a factor? 3. 3 and 9. And that's...
Five's got to be one. Nothing else. No.
Yeah, that's it. Which one do we want to try first? 1 and 27 or 3 and 9?
3 and 9, fine.
There's 9
And then if I
Oh, wait, no, it's not.
Okay. Now if we check this here, r times negative 9 is negative 9r. 3 times r is positive 3r, giving us negative 6r. So 5 times r plus 3 times r minus 9. And that's it.
Can I?
Yes.
Who's this little birdie?
You don't know who.
Worse than having to take a test. All right, guys. Questions on this here? Is this? Yes, this one here. 3x plus x squared minus 10. So what is the difference between this one and the previous ones we've done? X squared's in the middle, yes? So what we could do is put it back in standard form. And again, standard form is we take and make sure the term with the variable with the biggest exponent goes first and then goes down in decreasing order. And according to number theory, we do this also in alphabetical order. So if there's more than one term, so A, where the biggest power would go first, then B, C, so on and so forth. But here, we just need to rewrite it so that it's now in standard form with x squared plus 3x minus 10. Then we go through the process again. Is there a greatest common factor between these three terms? No. So we'll have two sets of parentheses with 3 spaces. The third term is negative, so the signs are opposite. Positive and negative. Now we want to find the factors of the first and third term. Factors of x squared are x and x. Factors of 10, 1 and 10, 2 and 5. Which one do we want to try first? 5 and 2. 5 and 2. X times negative 2 is negative 2x. 5 times x is positive 5x, giving us positive 3x.
Oh my goodness.
All right, guys. Questions on this here?
No, sir.
All right. We have two left. 2 examples left. We're going to look at this one here. 9x squared plus 30x plus 6. Is there a greatest common factor between these three terms? 3. So we'll factor the 3 out. Now, if we factor the 3 out of 9x squared, we get 3x squared plus, if we factor the 3 out of 30, x plus 2. So we need to somehow get the factors of our 3x squared and 2 to get 10, yes? It doesn't look like that might be factorable. But it would be nice to have a way to be able to check and make sure if a quadratic equation is factorable, yes? Yeah. And there is a way. And now y'all remember this equation, yes? We're not using the whole thing. Because if it's going to be factorable, our solutions are going to be rational. We're going to have a rational number, a number we can write as a fraction or a whole number, yes? Now, the only place in this equation where we could get an irrational number or an imaginary number is a part of this square root here. Because if this square root doesn't reduce, our answer is irrational, which means it won't be factorable. So if we find the square root of b squared minus 4ac, and we find that this here is a whole number, a positive whole number, it comes out nicely, then it means that's factorable. If this comes out with imaginary terms, what's inside of it's negative or does not come out evenly, it means that's not factorable or we can't take it any further. So for this here, what's the value of b? 10, so we'll plug 10 in for b, times 4a, 3, and c is 2. Now at this point here, it doesn't matter which calculator we're using because we're not actually trying to find a value, we're just trying to see does this factor. So if we take the 30xs, say second square root, 10 squared minus 4 times 3 times 2, and hit enter, we get 2 squared of 19. Is that a rational number? No, we have a radical, yes? Which tells us that this quadratic here does not factor any further.
No solution.
So that there's the answer. So it is factorable because we were able to factor out a 3, and that's as far as it goes. We can't actually take it any further. But the square root of b squared minus 4ac does give us a way to check and see this doesn't look like it factors. Let's try it and see. Because if we look at the previous, let's even look back here. Because if we started here, 5r squared minus 30r minus 135. So this would be the square root of negative 30 squared minus 4 times 5 times negative 135. So if I check this here, well, we know this factors. Second square root, negative 30 squared minus 4 times 5 times negative 135, we get 60. Now the 60 is not so much important. It's more that we get 60. We get a number that's not a decimal number, has no radicals, does not have I. This here is telling us that this is factorable. We can factor it. Does that make sense? And the reason that this is nice is especially when we come across these quadratics that do have a big first and third term, where it doesn't look like it's working, we can throw it in there, see, does this give us a nice number without a radical? That way we don't have to go through the whole process. But in either case, before we do that, always check for a greatest common factor. Is there a greatest common factor between these three numbers? No. You know what? Let's just go on and check it. Now, luckily for us, especially when you're doing these here, doing these on the homework or trying to see if they do factor. Got one? Yep. You don't necessarily have to write this out. You can just throw it in the calculator because it's square root of, so b squared 9 squared minus 4 times a times c. We say second square root. We're on the very back. Tried to look at the note sheet I had. 9 squared minus 4 times a times c. And as long as we get a number that doesn't have a radical from this as kind of the final solution, it means it factors. Here, that's not a whole number. So what does that tell us about this quadratic? It's not factorable. Did we have a greatest common factor? No. So this here is actually not factorable. It's already simplified as it gets. I can't take it any further. Yes. And no, each one of those is 1 day. So there are 7 pages in this AMI packet. That's no AMI packet. Yes. Now the homework sheet, the factoring 1. This worksheet, I will tell you this, there is one like this here, the last one, that is not factorable, does not factor, does not simplify at all. And there's one like this one here where there is a greatest common factor, but that's all we can do with it. So one that doesn't factor at all, one that just has a greatest common factor, but then the rest are factorable. So 10 out of the 12 are factorable. We can take them all the way down. One just has a greatest common factor. One just does not factor.